Good evening, everyone, and a warm welcome to Devfest25. It's amazing to see you all, developers, designers, dreamers, and problem solvers, joining us from all around, united by one passion, technology and innovation. Whether you come to learn, to build, or to connect, trust me, you're in the right place. For those who might be new here, Devfest stands for Developer Festival, a global celebration of technology, creativity, and community, powered by Google Developers Group all over the world. And just like every year, DevFest Algiers brings you a wonderful experience, starting by the talks and workshops, where you will gain insights from world-class experts. Now, before diving into the action, it's time to hear from the inspiring people behind this event. Let's first welcome our amazing GDG Algiers leader, Malik Amina.
Hello everyone and welcome to Devfest 2025. For the past 14 years, GDG Algiers has been organizing events, projects and activities to share knowledge, build community and inspire innovation. This year, we are excited to offer a series of talks by experts in cloud, AI and security, along with interactive workshops where you can learn by doing. A big thank you to our speakers, trainers, and the whole team who worked behind the scenes for making this event possible. We hope you will gain new insights, meet amazing people, and live inspired. Enjoy the Fest 2025 and keep learning.
Thank you so much, Amina. And right after, we'll be hearing from the one who keeps all the strings together, our event manager, Ilyas Boujabot, who will share a few words about this year's vision and what's waiting for you.
Everyone. My name is Lias Boujabert, and I'm the event manager of this year's edition of the Fest. So this is our version of the Fest. So as we all know, the Fest is an event that all GDG chapters organize all over the world. So it's a real pleasure to see all developers, innovators, and tech enthusiasts gathered here, and we've prepared an exciting lineup of talks, workshops, and activities just to allow you to discover different insights. And on behalf of the GDG Algiers team, I'd like to thank you all for being here, and I hope you enjoy this amazing experience with us. And also a special thanks to our speakers and trainers for this year's edition. And thank you, everyone.
Thank you, Amina and Ilyas, for those inspiring words and for leading such a passionate community. Now, let's move forward to what's next. And the next step is our first talk of the evening. We're picking off strong the world class speaker, Udash Udayakamur, also known as the Cloud Pilot. Udesh is an AI consultant, a Google developer expert, Google for Startups mentor, and an international tech speaker with a gift for making the cloud word clear, practical, and exciting. If you've seen his YouTube channel, Cloud Pilot, you already know how brilliant he breaks down complex cloud concepts. Today, he will take us on a journey through serverless CI/CD on Google Cloud, from fundamentals to enterprise delivery. CI/CD is the beating heart of modern software engineering. It's what allows teams to build, test, deploy software faster and safer and smarter. And today, we will see how it scales beautifully in the serverless world of Google Cloud. So without further ado, please welcome Udesh Udayakumar, the Cloud Pilot. Udesh, the stage is yours. Introduce yourself and take us into the clouds.
Thank you so much, Rafiq. It was a wonderful introduction. And hi, everyone. My name is Udesh, and it's my first time speaking at JDG Algiers. So thank you so much for inviting me. And I would love to see how I can share my knowledge about serverless CI/CD on Google Cloud to all our members who are watching this across the globe. So let me introduce myself again. Uday Kumar. I come from India, but I currently work at the Google Cloud Center of Excellence in Qatar. I am also a cloud and AI consultant. I've helped multiple companies, starting from startups to enterprises from various domains across fintech, retail, finance, as well as e-commerce and also healthcare, to build a lot of good solutions on Google Cloud. And I've been in this journey since 2020, and it's been a wonderful ride ever since. And also, luckily, I got recognized as a Google Developer Expert on Cloud. I became a mentor for Google for Startups Accelerator program in the MENA and Turkey region. And I am an international tech speaker. I've spoken in more than 120 events by now. And I'm also a technical book reviewer. I've reviewed multiple books which spoke about Google Cloud. And I also have a channel on my own called The Cloud Pilot, where I post content on cloud and Kubernetes. And recently I just started posting something generic about how our life look like. And also I write a lot of articles and blogs on Medium. So the link pilotlidesh.medium.com is where you can find my articles. So with that, I would like to move for today's topics, which is CI/CD, and then how you can build a CI/CD pipeline, and what are the different tools that you can use in Google Cloud. I'll be focusing on just three core services that can be used to build a CI/CD pipeline on Google Cloud, and I'll also discuss some of the best practices. So let me talk about CI/CD in the first place. So what is CI/CD? CI/CD stands for continuous integration and continuous delivery. And what does that mean? Now, historically, there used to be two processes where developers who builds applications and the operators, the people who are responsible for deploying this into the systems and to keep those systems actively running. So these two occurred to be two separate jobs, and the problem was there was a gap in between because developers don't know how the systems can be managed if there is a problem, and operators did not know how to change the code in case if some code breaks. So this used to be a very huge gap, which is also concerning. So to bridge these gap, that was where a culture of having a developer operations collaboration was into the picture. So that essentially became DevOps. So CI/CD is also part of DevOps. So CI/CD is essentially a practice within software development which can automate the whole process so that the gap can be bridged. And there are multiple ways of doing it. So continuous integration and continuous delivery are two separate things. Now, continuous integration is a practice for merging the code changes into a repository. For example, if you're a developer, you know you need to store your code somewhere, which is ideally in a version control system, where you have different code repositories and you push your code there. So for example, GitHub, GitLab, Bitbucket are some of these tools that you use for integration. And then these repository, the code in this repository can then be used to deploy into the systems. And that is where continuous delivery comes into the picture. So continuous delivery is a process where you make it short, but then you start deploying it as soon as something comes in, so that you can get the things into the market as soon as you can. So the best practice of any business in order to survive is to get the product into the market as soon as they can and identify and understand how the market dynamic works. So continuous delivery enables in getting the product out into the market at the nearest possible time, and at the same time it also ensures that there is least risk in terms of loss of service quality. So what are the benefits? The benefits of CI/CD is that since this is an automated process, it helps detecting the bugs sooner. Because now, let's say you developed a new feature and then you wanted to test it, you tested it out. And for you to test it out on a system where the users are using, you need to deploy it. So you deploy it, and then you see that there is some aspect of that feature which is not actually working in the way it was intended to work. So once they identify this, they can quickly come back to the previous version. They just change the code and then they start working on this. And if it's a minor fix, then probably in the next update, it's just going to happen immediately as possible. And second, it helps improve the code quality. Simply because when you develop code, you're writing the code to ensure that it doesn't break what is existing. And you don't want to break whatever is working. So there is a unspoken rule within the IT world that if something works, don't touch it. Just keep it working. So when you're writing a code, you also have to ensure that it doesn't break anything else. So when it comes to CI/CD, you also get to focus on the quick fixes and the small fixes so that you just focus and you put all your effort into making that better. So this in terms helps you in making the software much better. And then third is it helps in enhancing the collaboration because like I said, there are developers and there are operators. So how are each people or from each side finding the right way to collaborate? Because operators know how to deploy, developers know how to write code. Now, once you have a CI/CD practice in place, it's essentially going to take all these process in the middle and automate it. So if there is, let's say for some reason, there is a break in the production, you can simply roll out a new version and ensure that the stable version is currently serving the users. And then you take the faulty version and you start working on it. And then also it helps reduce the risk of regressions. And there are several stages in a CI/CD pipeline if you look at it. So starting off with a build stage. Build stage is where you build the application code, you write what the application has to do, you define all the features, you push the code to your version control system, your source code repository. And once you have the code in your repository, then you start deploying it. Because now you have the code locally or somewhere in your version control system. Now you need to test it out by deploying that software for others to use. So that's where the deployment stage comes in. And once you deploy, it's currently actively hosted on your systems, and now you can start testing it. Once you test it and ensure that there are no bugs, there are no errors, it's working as intended, it's working fine, you can improve it and ensure that this is going out to the users. And essentially, there is no single version of a CI/CD pipeline. This is also something that a lot of people don't think about because everything is usually generalized. So there is no single version of having a CI/CD pipeline. There are different ways of doing it, like I mentioned earlier. So one way is manual pipelines where there is no CI/CD. You just write the code, push it to the VCS, then you start deploying manually. And then the second is using package tools with a fixed set of built-in automation. So you kind of use templates. And when you use those templates, a lot of those activities are automated, but at the same time, it's not fully a centric solution, a centralized solution where you can have it end to end. And the third one is a dev-centric, which is a developer-centric CI/CD. And the fourth one is an op-centric, which is an operations-centric CI/CD. So dev-centric CI/CD is where the developers can have an automated pipeline, which helps the developers to do the code pushes. So everything around the operations will be automated and the developers simply just have to focus on writing the code, pushing it to code repository. And op-centric is where the system operators, they can focus on getting their systems work ready. So it takes the code, pulls it out, then it starts deploying. And then on the deployment side, it can then be further fine-tuned. So some of the CI/CD tools in the Google Cloud Marketplace, so not just the native Google Cloud CI/CD tools, but there are also several other CI/CD tools which are open source and other paid tools in the marketplace. So these are some of those tools which you can purchase through Google Cloud's Marketplace if you don't want to use the native services. We'll come to the native services in a bit, but these are also some of the popular services that has been used across. So the most popular and the oldest open source CI/CD tool is Jenkins. I'm sure at least half of this crowd has heard of Jenkins if you're in the IT industry. And then there is also Spinnaker. Spinnaker is used again for continuous delivery. There is Circle CI, which is an integration platform. There is GitLab CI, which is another integration tool built into GitLab. And then even on GitHub, there is GitHub Actions. And then there is also Drone, which is a CI/CD platform built with a container-first architecture. So if you prefer to use any of these tools, then you can purchase them on Google Cloud Marketplace if you're using Google Cloud. And now coming to the Google Cloud's native CI/CD tools, Artifact Registry, Cloud Build, and Cloud Deploy. So we will talk about these three tools in the upcoming time. So talking about Artifact, what is an artifact? Artifact is essentially an output produced at each stage. So since you have the CI/CD pipeline, every stage produces an output. So every stage you create a product. For example, let's say in the initial build stage, you have the compiled code. You're compiling the code. You're pushing it to the version control system and you're compiling the code. So the compiled code is an artifact. And then you start deploying it. Once you deploy it, you get the test results. And then you have the deployment packages. So these are all artifacts, and these needs to be stored at some place because that becomes the input for the next stage. So artifacts are very essential if you want to reproduce builds, and very much essential if you are doing it consistently. If you're deploying consistently, then you must need it. And also, artifacts help in ensuring that the software that you're delivering is the same. So let's talk about Artifact Registry. Artifact Registry is a managed service. So like I said, in my title, it said serverless. So what is serverless? Serverless means it's not that there are no servers, but the operations or the management or the administration of the servers behind those services are automatically managed by the cloud provider. So in our case, Google Cloud is going to manage all these services administration. For example, updating these services or doing a maintenance, everything is taken care by Google Cloud. So Artifact Registry is one such fully managed, secure, and scalable artifact repository. So you can store all the artifacts, you can manage the artifact, you can even distribute the artifact into different repositories. And these artifacts can be any type, for example, the source codes, or maybe some of the binary dependencies, or any Docker images if you want to store any container images. All of these can be securely stored in Artifact Registry. Now, some of the features is that it also acts like a version control system for artifacts. So whenever you push the code into these systems, it essentially keeps a track of how many images you have pushed, what are the images, what time, what version, everything is kept, so that it also helps you in debugging if there are any code errors or any bugs that you're finding. And second is there are retention policies. So there is a way to retain or delete all these artifacts for a certain period of time. So this essentially reduces the risk of data loss and also frees up storage, because when you're storing on Artifact Registry, you're paying for the size that you have consumed. So whenever you're storing images, the size simply gets added up. For example, let's say you have your Google Drive space, and whenever you're adding files, your Google Drive space is getting consumed. And if after a certain level, you have to start paying for those amount of data. And essentially, even when you're using a cloud service, you are paying for what you're using. And in terms of Artifact Registry, you pay for the storage. So there are retention policies which allows you to retain the data for a certain amount of time, simply because you don't want to store everything, because you are paying for the size you are consuming. And the third feature is different access controls, which means you can protect sensitive artifacts and you can define who can view, who gets access to these artifacts. So with a tool called Identity and Access Management, IAM, you can manage who has access to what and how each artifact can be managed with the respective stakeholders. And also webhooks, you can also send automated notification to specific URLs. So Artifact Registry also supports webhooks so that you can even keep track of all the changes. And the second tool that we're going to talk about is Cloud Build. So Cloud Build is another serverless service which can automatically start the building processes. So it can import all the source code from a variety of repository, let's say GitLab, Bitbucket, or GitHub. It can import all the source code from the repository or even a cloud storage space, and then it can execute a build to the defined specification. So within Cloud Build, you define something called as a YAML format specification where you mention the steps. What are the steps that should happen? What are the code that you should run in the build process? So you can define the steps, and for each step, you define what kind of code. And then you can also use Cloud Build to produce the artifacts, for example, like container images. So let's say you have some code on your GitHub. You can define a Cloud Build pipeline which can pull the code from GitHub, start executing, compile the code, and create an artifact image. For example, let's say a Docker container. So it's going to pull all the image. There will be a Docker file. It takes the definitions in the Docker file, it runs it, it takes it, pushes it to Artifact Registry, and it can even do a deployment. So all of these processes are done automatically through Cloud Build. And Cloud Build definitely can interact with Artifact Registry, Cloud Storage, even GKE, or even Cloud Run if you want to run serverless containers. And it also has a built-in support for Docker, Git, kubectl, which is the tool that you use to interact with Kubernetes, and also Helm. So Cloud Build also has a trigger mechanism, which means whenever there is a change within your code, Cloud Build triggers can monitor these and identify the change. And whenever you push the code to your GitHub or GitLab or Bitbucket, Cloud Build can automatically identify that there has been this change in this branch or this repository, and it should start a process to update the artifact. So Cloud Build can automatically do that. And then there is also Cloud Deploy. Cloud Deploy is a deployment service which automates the deployment of the application to GKE, which is Google Kubernetes Engine. So Cloud Deploy is a CD tool, a continuous delivery or a continuous deployment tool. So this can be used to deploy all the artifacts to different environments. For example, let's say if you're a company which is trying to host an application, that definitely means you will have multiple environments. When you're building these solutions, you will have a development environment where you develop all the features. There will be a staging where you're staging all the applications, ensuring that the testing process, everything is well and good for the application to be published to the users, to the public to use. And that is production. So you have three different stages in this example. You have a development environment, you have a staging environment, and you also have a production environment. So Cloud Deploy is that tool which allows you to deploy the same artifact to all these environments in a sequential manner. So for example, let's say you have the dev, stage, and prod. Now, once you set up Cloud Deploy, you can first start deploying the same artifact on development environment. And once you see that everything is working well and good, you move to staging. The staging deployment happens, and then you can also have an approval mechanism where once it works on staging, you approve, and then it gets deployed to the production. And then it becomes the single centralized place for you to view and manage all your deployments. Now, the best part is it can also be integrated with all the other Google Cloud services. So in terms of cloud monitoring, if you want to monitor the status of these solutions, or if you want to see the logs, you can use cloud logging. And if you want to see any errors, you can use error reporting, which is another service under the Google Cloud operations. So all of these features are also available on Cloud Deploy. Now, some of the features is that you can use different source code repositories, GitHub, Bitbucket, GitLab. You can use from many sources, and you can even use container images, for example, like a Docker image or any artifact registry, Docker registry. Different repositories can be used for the container images as well. And it also supports different deployment methods. So when it comes to the containerized deployments, when you have containers, there are different mechanisms on how you can start doing the updates. So the application updates, some of the ways of doing these application updates is the different deployment mechanisms like blue-green deployment, canary deployment, and even rolling updates. So it also supports, Cloud Deploy also supports in delivering in any of these approaches. And why is that mostly helpful? Because it helps Kubernetes deployments in terms of reliability, scalability, as well as security, because all the security mechanisms can be applied to Cloud Build and Cloud Deploy in terms of building a CI/CD pipeline, and also in terms of reliability and scalability, because these are all managed services and these can efficiently deploy the applications to your place of hosting. And then coming down to some of the best practices with CI/CD is one, use a managed artifact repository. So this is essentially because the primary intention of using a CI/CD a mechanism, or the best intention is to automate the whole process, because we are humans, we can make errors, and errors or human errors are inevitable at some point. Even if we put all the focus, at some point something might go wrong. So how can we avoid that? By not touching it. So how do we not touch it? By automating a process. So the first practice is to use a managed artifact repository. When you use a managed artifact repository, the vendor is responsible for managing all the artifacts within that repository. So you don't get the whole of the overhead. The operational overhead is not on top of you. So this helps you in focusing on your job much better. And the second is to use a build service, for example, like Cloud Build. When you use a build service, you are again automating all the steps. Now you're running the steps and it's running on its own, and you find the logs, you check the logs, and you can monitor it live. And then you see what's the status of the deployment, as well as you see what is happening in those steps. And the third best practice is to use a deployment service, because again, automating the step and using a deployment service which can manage the deployment of the application, so that you just don't have to worry about what if you have to deploy it manually and something goes wrong. So you don't have to think about any of those. You just simply use a deployment service and you just get started with what you want to do. And the fourth best practice is to automate your pipeline. Never let a human touch your pipeline stages. Just make it automatic. Don't let anybody interfere into the pipeline. Don't let anybody enter in between the pipeline. And also the fifth best practice is to monitor the pipeline, so that you have full visibility about what is happening to your system, what are the updates, where you are, and how you want to be. And this essentially helps in making sure that whenever you're making a deployment, you're staying vigilant. So with that, I think we can wrap up with the talk. I think I've been speaking monotonously for a long period of time. Now I'll take a pause and see if you have any questions. I hope you were able to get something out of this, and you got a bit of new information about the different CI/CD tools that you can use on Google Cloud. If you have any questions, I'm happy to answer.
Thank you so much. It was really valuable information you just shared with us. I personally learned a lot. For the question, if anyone have any question, just put them in a chat in any platform or on the platforms, and we can just share them to Mr. Yudesh. Someone said, is CI/CD something only large companies need, or can small teams and startups benefit just as much?
CI/CD is something which everybody can benefit, especially, let's say, if you're a startup. This is a place where you can make mistakes, but at the same time, it's not just about making mistakes, but also about making sure that you are not breaking up things. So let's say for a startup, you're just probably a developer and you don't know extensively about systems or what to do if any systems break. So in those cases, this is very essential, very helpful for a developer who is building on applications. So especially when you're using these developer-centric CI/CD tools, it essentially lets you focus on just building the application. Once you have the CI/CD pipeline established, you don't have to look back. All you have to do is just focus on building the application code, pushing it to your code repository, and the whole process gets automated. In the end, you just test the application and see whether it is working in the way you intended. So it can help every organization, regardless of the scale that they're working on.
Thank you so much. Another one said, how can we ensure that our CI/CD pipeline is resilient and capable of recovering from failure effectively?
Okay, so essentially, there are certain mechanisms of how you can design your CI/CD. So the first process in terms of the resilience is to ensure that it is automated so that nobody touches anything. So what do I mean by the automation? Automation is where you write a template format so that it for every step it follows the same process. So that's what I may mean by automation. For example, if you're using infrastructure, if you want to provision infrastructure, use tools like infrastructure as a code. For example, there is Terraform, which can help in provisioning infrastructure. So this helps in creating the services. And then the second one is to decouple the components, because again, like when I said, there are artifacts. Artifacts are outputs that you produce in between each stage. So when you use that, when you separate the build stages, this essentially helps in building an effective solution. So if there is a failure in one stage, it still doesn't affect the whole. And the third is to use a version control system, because anytime you make a change in your code, you also need to ensure that you are able to go back and trace what changes you have made. So having a version control system also helps. And then also in terms of, let's say, for redundancy, in terms of reliability, what you need is redundancy. So ensure that you are using a managed service so that the vendor can automatically ensure that your processes are not getting disrupted in between. And then in terms of failure recovery, you can have automated rollbacks. So you can take backups, you can have retry mechanisms, and also use different kinds of delivery mechanism. For example, like blue-green deployment, where you simultaneously have both the environments and then you switch the traffic, or you use a canary deployment where you can just have a canary deployment on the one side and then you route a portion of the traffic there while you update all the existing systems. And then, of course, building the monitoring and the logging capabilities, ensuring that you have a alerting mechanism in place. So once you have all of these, it will ensure that your CI/CD pipelines are resilient and capable.
Thank you so much. Another one said, how we can use AI to improve CI/CD in nowadays.
Okay, this is a very interesting question, because this is also something that I kind of explore on, because AI has kind of become an integral part of our lives. So one of the best things that you can do is to identify, like the person who asked this question, is to identify how you can use AI to make this better. So one way of doing it is, collect all the best practice documentations using AI, so that you don't have to search manually, and then fill all, or you just transfer all these documents into maybe, let's say, a notebook LLM, or even Gemini for a Google Cloud LLM, and ask questions about what are the best practices that they should follow for this organization coming from this background. You're a person coming from this background, and what are the things that they should be aware of. Or let's say you are a company building this product in this industry, and this is the what to say, kind of target audience that you're looking for, and then ask questions based on those. How should I design my CI/CD pipeline? And also, in terms of, let's say you already have some existing um, systems or pipelines in place, you just have the architecture diagrams and the configurations. So by explaining the type of configuration that you have right now, you can also ask, am I missing something? Is there anything which I can add to make it much better? So plenty of ways to use AI, or even for that matter, you can even ask Gemini to, okay, write me a CI/CD YAML file, a cloud build.yaml file to build a cloud build pipeline for building the image, pushing it to Artifact Registry, and pushing it to GKE. And then it continues to generate the code, and you can read through the code, ensure that the code is working, and then use that code. So there are multiple ways of using AI.
Thank you so much again. There is another question. Will there be a practical demo?
I have not prepared for a practical demo. I thought this was a talk, so I haven't kept any practical demos. Again, it's a bit technical, takes a lot of time, so I've not prepared anything ready-made. Sorry about that.
Okay. Another question. For a normal programmer, how I can get the role to design CI/CD? I think he mean like the previous knowledge that he has to have to get to CI/CD.
Yeah. So essentially, CI/CD is a part of DevOps, which is developers and operators. So the main thing, if you're a developer, I would suggest is to learn about systems, how systems work, and make sure that there is what is the process behind CI/CD that lets developers not worry about what if the system breaks or what if the deployment fails. So learn about how the systems work, learn about how these applications work for each systems, what are the dependencies required, and how does these systems perform for each kind of application. For example, Python is a memory intensive program as compared to C++, which is faster than Python. So there are certain differences when you're choosing the programming language. So learn about how each programming language affects the system's performance, and try to understand the other infrastructure aspects, for example, like the network. So there are different types of network. And then, for example, there's shared network, which is called shared VPCs. There are standalone networks. There are subnetworks where you can segment these networks into different categories. So there are different types of network. There are different types of compute servers. So learn about all these systems, and then this would essentially help in building an effective solution. And this knowledge is what you need to transition, if you are looking for that, to transition into a DevOps role. Learn about containers, learn about Kubernetes container orchestration, learn about container images, microservices, and this should essentially help you.
All right. Another question. What makes CI/CD different in serverless compared to containers?
Okay, so essentially you are with CI/CD, you are deploying containers. So CI/CD is one way of deploying containers. And in terms of serverless versus servers is that serverless is where the vendors take care of the management or the administration. So you pay for the vendor instead of paying some employees a certain salary to manage those systems alone. So that's the primary difference between serverless and servers.
Okay. Another question saying, should we build our images in CI and pull them from a registry, or build them directly on the server? I am comparing performance, security, and consistency.
Okay, so building the image in CI and pulling them from a registry is essentially the most advantageous because simply because of a few reasons. One is you get a centralized platform for managing your artifacts, and instead of building from the server. The second is even when you are building these artifacts, you again don't know what's if there are any vulnerabilities in your systems or the images that you're using. Is your artifact safe to be deployed? Is there any security concerns? Is there any, let's say, uh, caching required? Or let's say, is there any way of deploying things? If you have it on a registry, it helps better to resolve all these questions. And if you're building them directly on a server, you're essentially increasing the load on the servers, so which is going to increase the compute and which is essentially in turn going to increase the cost. So in terms of performance, definitely have your images from a CI platform. So keep it on an artifact registry. And in terms of security, you can apply, even when you have it on your artifact registry, you can apply security mechanisms. Let's say you can sign the image and ensure that only the verified images can be deployed. So in terms of security, also it offers more advantage. And even in terms of consistency, it's a version control system. So it also helps in controlling the versions. Let's say you are building 5 new versions of your image every time you make an update. So it also helps in their so that in terms of consistency, also it's maintained through the versions.
All right, thank you so much. I don't see any more questions, honestly. So I would have to thank you again, Mr. Yudesh. That was truly insightful. Thank you so much for showing us how automation and cloud technology can transform delivery pipelines at every scale. Uh, so yeah, thank you so much, Mr. Yudesh.
Thank you very much for having me. It was a pleasure. Thank you for inviting. Looking forward to meeting you again.
Thank you so much again.